pretty quick. Okay, simple trinomials. So we've worked a little bit with this already. Simple means it starts with a 1x squared. That's why it's called simple. Trinomial because it has the 3 parts. So the rules is always 2 brackets. The first times the first in your bracket sets have to make x squared. So therefore you're always going to have x times x. The last and the last in your brackets need to multiply to this and add to the middle. So you have to think about your multiples of 15. 5 and 3 are the multiples of 15, and then you got to play around with plus minus because this is minus 15. So there'll be a plus and a negative 3. Okay. Did you notice how I still wrote my equation? So I wrote equals 0 still. So that's a deduction if you forget to write that. So what is the solution for x? So what number causes the bracket to be a 0 value? Okay, this is how I write it. Another way to write it, if you wanted to write it as a coordinate, it technically would be this is correct, this is correct. Because it equals 0, which means the y is equal to 0. That's what's happening, right? These are my x-intercepts. The y is 0. Here's somebody who often does this that is incorrect. That is incorrect, writing it like that. Why did that person get that answer wrong? Yeah, they made a point. They put a point somewhere on the grid instead, right? So don't do that. Okay, can you try the next one on your own then? Multiplies to 30. Multiply to 30. And you got to make those numbers add to 11. Okay, did we match? Multiplies to 30. Do you understand what this is all about again? What does it mean? It means my parabola, my quadratic, has an x-intercept at 5 and at 6. This is what it's all about again. Okay. The next one is actually not a simple trinomial. It's close, but it's not. It starts with a negative x squared instead of just a 1x squared. Okay? I don't like factoring with negatives, ever. It's hard to do. So what's the strategy? I could factor out the negative 1. Okay, what is your new trinomial if you say the negative 1 is coming out of all those numbers? So this would now be positive x squared, positive 13x, and positive 22. So you can just change the signs to them all, right? Okay, now I'm going to work with that simple trinomial. So now it follows my rules. X and x, something that multiplies to 22. Did you get something multiplying to 22? 11 times 2? Plus plus? So I'm going to cue up your visual here. What does it mean? There's an x-intercept at -2 and -11. But what's the difference in this situation? What does your parabola look like? Flipped. Okay, that's the difference on that one. But the x-intercepts are at those spots. Okay, GCF. So this was from grade 10. So GCF means what can I divide out of each, every single term has to have it in it. So what does every term here, there's two terms, what do they both have in common? X. I want you to think about GCF like this. So there's two terms, so I have to have two swivels. X times what makes x squared? X times what makes the second term? Negative 12. So I would like x to equal what or x to equal what? There's going to be two numbers there. So if I want this to be 0, x would have to be, if I want this multiplier to be 0, x would have to be 0. And if I want this multiplier to be 0, x would have to be 12. Does that make sense? 0? If x was 0, it would be 0 times another bracket, right? Okay, number 2, there's 3 terms. This, and this all have a what in it? An x again. And this time there's 3 terms. So you're going to have 3 swivels. Okay, so then your brain is going to go x times what makes the first unit? X squared. X times what makes the second unit? 3x. X times what makes the third unit? Negative 18. We aren't at the solution stage. We actually have to do one more step. Anybody see what you would do here? What is it going on right there? There's a simple trinomial. Okay, so this simple trinomial will create 2 more brackets. But here's the important thing. You have to also carry that x down. People forget that. So the x is still there, and then this trinomial will break down. So what multiplies to 18? We've got some numbers that will work with the 3. 3 times 6, 1 is plus. So this one has 3 answers for x. X could be something, something, and something. There's 3 numbers. So do you remember this one? 0, negative 6, and positive 3. That's a whole nother ball game to graph. You learned that in grade 12. We graph those. Okay, the next one is 2 terms. So is there anything common between those 2 terms that you could divide them each by? This and this are both divisible by 4 is true, but something else. 8. It's called the greatest common factor, so you always want to try to take out the biggest, greatest. So 8 is the biggest, and there's 2 terms, so you have to think like that. 8 times what makes that? 8 times what makes that? So 8 times x squared, 8 times -4. Ooh, we ran into something else. What is that? Difference of squares. Okay? Difference of squares. So, 2 brackets. So, first times first has to make x squared. X times x. Last times last has to make -4. And what do they have to add to in the middle? 0. Right? Because there is no middle. There's no middle, so they have to add to 0. So, plus minus 2. So that's how difference of squares always works. It's always the same numbers, right? Okay, so I have a -2 solution for x and a +2. This 8 is there's no x in that part, so you don't even look at that part, right? Okay, and the last example today. So this one is a difference of squares, so give me 2 brackets. Difference of squares, give me 2 brackets. What times what makes a fourth? A squared and an a squared. Plus minus, you okay with me doing that? Right? Does that make sense with the difference of squares? It's always plus minus. What times what? What's the square root of 256? 16. So plus 16 minus 16. Oh, I see something else. I'm going to keep going. What else can I keep factoring? That. What is this? It's another difference of squares. So a times a, difference of squares, so plus minus something that makes 16. 4. What do I do with this? I need to just rewrite it. That's not factorable. Why is it not factorable? It's a plus. If I want to think about it, to make this bracket be 0, this position would have to be -16. Can you square anything to make -16? No, I can't, so that's why I can't factor it anymore. If there's going to be no solution, it's not factorable. Okay, but this means my solution is -4 and +4. Okay, and then that piece is just sitting there, but doesn't get factored.